This protocol shows how to pattern oxide-free silicon and germanium with reactive organic monolayers using a highly efficient and operationally simple printing protocol. Selective functionalization of the patterned substrates with both small molecules and proteins is also demonstrated. The first step of the protocol is to covalently modify passivated silicon or germanium substrates with a highly stable primary organic monolayer. This protects the underlying inorganic-organic interface from reactive degradation and oxidative damage. The covalently linked N-hydroxysuccinimide ester overlayer is formed to provide latent hydrolytic and reactive functionalities. As a second step, the uniform bilayered NHS-modified substrates are patterned by catalytic microcontact printing using a patterned sulfonic acid-modified elastomeric stamp. Contact with the stamp hydrolyzes NHS groups, thus forming patterns of chemically distinct NHS-activated and free carboxylic acids. Next, the patterned substrates are functionalized with small organic molecules and proteins. This step is completed by first affixing nitryllotriacetic acid terminated heterobifunctional linkers to the NHS functionalized regions, and second by selective attachment of hexahistidine-tagged green fluorescent protein. The approach produces excellent results with patterns of differential fluorescence intensity that are quite clear and a pattern of integrity that is remarkably stable after multiple surface modifications.
So the main advantage of this technique over existing methods is the accuracy. The pattern is really controlled by the accuracy of the stamp itself as opposed to diffusion. The project was originally initiated from the idea that patterning techniques that rely on catalytic reaction as opposed to simple deposition must have numerous advantages. For one, the catalysts aren't consumed in the reaction and it can be reused multiple times, unlike traditional printing or deposition where you can